don't lose any work that we do here, let's save this empty scene, or this basic scene here. We go to File, we hit Save Scene, and after that we're going to save this as game.unity. Okay, so how scripting work in Unity? Notice that every game object that we have in this hierarchy, as we see in many other lessons, and well, if you have used Unity for 5 minutes, you're going to notice this, we have a list of components for every of these game objects. And the way scripting works in general in Unity is you create a script file, which is, it could be written in C# or JavaScript, for example, and you attach this script to a game object. More precisely, you're going to add a script as a component for the game object, and that allows you to basically write any custom behavior that you want. Okay, so Unity provides us with things like physical collisions, we can have materials, we have some 3D primitives, but if we want to do anything that's a tiny bit more complex than what we have in Unity, and well, we're going to need to do this if we want to make some fun games, we need to go to scripting. So we're going to start by making a script for this cube. We're going to our project window, we're going to right click, select Create, and we're going to choose C# script. A new file is going to appear in the Assets folder, and we're going to rename this as Cube. Okay, now we hit the Enter button, okay, the Enter key. Let's wait for the compilation to complete, and notice that every script file that you add is going to trigger a little spinning wheel in here. That's basically to tell you that the compilation is happening. Okay, it's a process that is going to get all the lines that you write in your code, and it's going to convert to a format that is better for your game to process. Okay, this happens every time you change even a character in your code. Okay, it needs to recompile the project to see if everything is going well. If something goes wrong with your code, then you're going to have to use the console window. Okay, if that is not enabled here, you can just go to Window and press the console button. So the console window is going to show you details, and better yet, it's going to show you messages regarding your project. So if you make any mistakes in your code, so if you forget a character, if you used an invalid variable name, for example, you're going to see some messages with a red sign in here, red icon, like this one. Okay, to tell you that something is wrong. It's going to give you a hint of what's wrong, and well, it's up to you to fix the code. If there is something that could be better written, okay, if there is a way to optimize the code, or maybe there is something that you created but is not being used, you're going to see a warning, which is going to be a message with this yellow exclamation point here, exclamation mark. Okay, so it's just something that is not going to stop it's not going to make the game stop working, but still it's something to keep in mind. And you can also add some simple log messages, some well, informational messages. For example, if we're testing our game and we want to see the value that is stored in a variable, we can just print its value in the console. Okay, so you can, well, see how it's going. This is very useful for debugging your code to see if everything is running properly. Okay, so now that you created this script, notice that you may try to open the script and try to write some lines in here, but right now this script is not going to be executed because it's attached to nothing. Okay, so we made a script file, but we need to attach it to something. To perform that attachment, we can just select this cube script, drag and drop here to the cube game object, and you notice that there's this cube script file in here. Okay, there's a little component that has been added to the cube game object. Or if you have the cube selected and you have the inspector open here, you can just drag and drop the script here. Okay, so now for this cube we have a fourth component. Okay, we have transform, mesh filter, box collider, and mesh render, and now we have this cube script. So let's start coding. We're going to double click this cube file, and once you do this, you notice that MonoDevelop is going to open. This software is great for coding. Okay, it's a coding interface, it's free, it's open source, it already comes with Unity, so if you didn't change any of the default settings, it's going to be installed. But if you want to use any other tools, if you want to use Visual Studio or Sublime Text, Notepad++, whatever you think is good for you, if you're used to it, then you can just configure Unity to use this text editor by default. Okay, you're not it's up to you to choose whatever you want. Okay, and now that this software opened, we have a little we have a few lines written in here. Okay, it's not an empty file, so we need to understand what's being written here. Okay, and to start, I'm going to delete these lines here. Okay, so let's start with just this. Okay, these first two lines here are basically including namespaces. Okay, and namespaces, imagine like namespaces are folders with several utilitarian files, utilitarian definitions. Okay, so when we say using Unity Engine, it means that the code that we're going to write here is going to use some things that were already implemented in the Unity Engine. And when we say using system.collections also, for example, it means that we are able to use certain parts of the code that were already written in the C# environment for collecting objects together, for example, by using arrays, using lists. You're going to see a little bit about this soon enough. Okay, but essentially, this means that we don't need to reinvent something that's already done for us. Okay, it's very important to keep that in mind. Sometimes we have some pride. We want to create things from the ground up, but to keep things fast and to make us focus in the game instead of writing something that is already done, we have to take a look at what tools we have available for us. So that's why we use these lines. Okay, and this block of code here is basically the definition of the cube class. Okay, so whatever we write between these curly braces is going to be changing how the cube is behaving. Okay, and these curly braces, they are basically defining the scope of this class. Okay, so here we say that we are defining a class called cube. This cube extends monoBehavior, which is the base class for every game object that we're going to use, and whatever is between these curly braces is going to be, well, the actual definition of the class. It is very important to understand these two characters here because they define the scope. They define what is going to happen once we enter here. Okay, and the first thing that we want to look is variables. Okay, what are variables? What are they for? Variables are basically a way that we can use to store data in the memory. Okay, so you have a running game or a running app, for example, and for instance you want to store the age of the player, or you want to store what time is it right now, you want to store if it's raining or not, you want to store an email. So data can be stored by developing apps. Okay, you can just allocate a position in memory. You can allocate a certain amount of memory to store some data. So for example, for the cube, we may want to create a variable that is going to change the size of the cube. Okay, because right now, if you go to Unity and take a look at the cube, the size of this cube is 1, 1, 1. Okay, you just check the scale property. The size is 1 on X, 1 on Y, and 1 on Z. But maybe we want to modify that scale. So how do we do this? We can go to the cube script in the definition of the class and type here public float size modifier, and we're going to set that to be 2.5f. Okay, so let's take a look on what we've just written here. First of all, we are saying that the variable that we're declaring has a name that is size modifier. Okay, we don't need to memorize a random number like this one. Okay, that would be an address to a certain position in memory that would store this data for us, but we can use whatever name we want. Okay, of course there are some restrictions, there are some reserved words, but in general there are no conflicts here. I'm just declaring a variable called size modifier. Okay, when I type float, it means that I'm saying that size modifier is going to store a floating point number. So it's a number that contains a decimal part. Okay, it's not a whole number like 1, 2, 3. It could be 1.15, 2.3, 3.1415. It could be numbers that contain the decimal part. Okay, a part that is lesser than 1. Okay, when we add this public keyword, it means we are changing the access modifier for this variable. So this means that this variable can be accessed in other places, so other classes can access it, and better yet, this is something that is going to be editable in the Unity editor, and I'm going to show that to you soon enough. Okay, so this declaration could end here. Okay, it could be just size modifier, float, public, and a semicolon to finish this statement. But we can already initialize it. We can start by already storing a value in here. So we use this equal sign. this equal sign is not used for storing, for making comparisons. So, for example, you don't want to ask if 1 equals to 1, for example. That's not how you compare things. You're going to see that soon. When we use an equal sign on only 1, it means we're making an assignment. So whatever we put here is going to be stored in this variable, size modifier. Okay, so if we use 2.5f, it means that we're storing 2.5. Okay, the dot basically separates the whole part from the decimal part, and f is just to say that this is a floating point number. It is important to have this character here. And now, if you save this script and go to Unity and wait for this compilation to happen, then if you look at the cube script, you're going to see that now you have the size modifier variable in here. Okay, so it's exposed in the editor. So if you want to change the size modifier, you don't need to go to this script and change the number and then wait for another compilation. That would take a lot of time. It would spend a lot of time. So it's very good that we can change things in here. So while the game is playing, we can change these variables and see how it impacts the game. Okay, that allows you to focus more on the game design. Okay, so you want to do something that is fun. You want to do something that's going to make the player to feel nice, for example. And to do that, you need to really test a lot and experiment a lot until you find the values that just feel right. Okay, it's one of the greatest things of having this here. Okay. Notice that we used a floating point number, size modifier, but let's say we want to store a name, for example. If we want to rename the cube, how do we do this? We can make another variable, so we can type here public string new name equals to, and let's start with an empty string. Okay, so we made a variable called new name. We say that the type of this variable is string. Okay, so it's a collection of characters. And we say that it's public, so it can be accessed in other places, even in the Unity editor. And we start by using this string here. Okay, every string that we make, any text that we want to write, needs to be enclosed by double quotes. Okay, so for example, if we want the name of this cube to be QB, okay, I'm not very creative today, but well, QB, or I don't know, Mark. Anyway, let's use QB. Then this is going to be the string that's going to be used here. Okay, we can type whatever we want. We can use special characters. We can use an exclamation mark. We can use numbers. Okay, we can use well, pretty much write any text that we want in here. Okay, and if we save this and go to Unity and wait for this compilation to complete, we're going to see the string again. Okay, we have a new field. New name, and well, the one that we wrote there is going to be here, but if we want to replace this to something else, like QB42, for example, this is the value that is going to be used. Okay, and now that we did this, let's take a look on one more type of variable. Okay, and this one is very interesting because it's going to be used in other classes. Okay, so we can make a public Boolean variable. Okay, so what is a Boolean variable? This is very interesting when you're programming, because a Boolean variable can have only two values. Okay, numbers can have millions and billions of different values, but Boolean values, they only have two. It's either true or false. Okay, so you say that, well, for example, we can change, let me see if we can change something in this cube. Okay, maybe we can make a variable that is going to say that the cube is going to be rotated or not. Okay, so we can add public bool is rotated and start as false. Okay, so a better way to visualize this is to simply save the script and go back to Unity and see the new field that is going to appear here. Notice that different from the size modifier that is a floating point number and the new name that is a string, is rotated is a checkbox. Okay, because we only have two different possible values. True, so it's checked, or false, it isn't checked. Okay, so it is interesting to see how this works. Okay, and the Unity editor is going to help us a lot with this. Alright, so now that we have these three variables in here, let's say we want to actually make them work. Okay, so what if we want to change the size of the cube to this? What if we want to change the name of this game object to this value here, QB42? And what if you want to make the cube to be rotated? We're going to learn how to do this by the usage of methods. We're going to see this in the next video.